At first they laughed. The German Luftwaffe, proud of its Messerschmitts and Focke-Wulfs, dismissed the American Republic P-47 Thunderbolt as a brute, too big, too heavy, too slow to ever challenge the elegance of German engineering. They called it the flying tank, a joke among pilots who prided themselves on the agility of their machines. But by 1943, the laughter began to fade, and when German test pilots finally flew a captured Thunderbolt, they stopped laughing altogether. The P-47 Thunderbolt was unlike anything the Luftwaffe had seen. Weighing nearly 8 tons when fully loaded, it dwarfed the nimble Bf-10-9s and W-19s 0S that ruled the European skies. To German eyes, it seemed absurd, a monster with wings, yet it carried one of the most powerful piston engines ever built, the 2,000 horsepower Pratt & Whitney R2800 Double Wasp. Its sheer mass and strength were its secret weapons. At first, German pilots thought it was an easy kill. Reports from the front described the Thunderbolt as sluggish in climbs and heavy in turns. The Luftwaffe's aces, men like Galland and Barkhorn, considered it inferior to their own designs. But then, missions over Western Europe began to tell a different story. Thunderbolts that should have fallen from the sky kept coming back. They were riddled with holes, missing cylinders, sometimes flying with half their wings shredded. And yet they landed safely. Luftwaffe gunners who saw them dive from 25,000 feet into a vertical descent at over 500 miles per hour swore no aircraft could survive that. The P-47 did, again and again. When the Allies began their relentless bombing campaigns over occupied France and Germany, the Thunderbolt was there, not as a bomber, but as its guardian. It escorted flying fortresses deep into the Reich, engaging Messerschmitts and Focke-Wulfs in brutal high-altitude duels. The Germans soon realized the truth. This was not a clumsy giant. This was a brawler of the sky, fast in a dive, impossibly tough, and armed to the teeth with 8.50 caliber machine guns. In 1943, the Germans captured one relatively intact Thunderbolt after it crash-landed near Caen. It was sent immediately to Rechlin, the Luftwaffe's secret testing base, the same place where they had studied the Spitfire and B-17 before it. The engineers and pilots were eager to see what made the Americans so confident in this ungainly beast. They would soon learn. When they stripped the Thunderbolt open, the engineers were shocked. Its internal structure was like nothing they had seen. Thick armor around the cockpit, self-sealing fuel tanks, and an engine so powerful that it could run even after being hit multiple times. The Germans began to understand that this aircraft was not built for elegance. It was built for survival. And when the Luftwaffe's best test pilots took it into the air, they discovered something far more terrifying. The day the captured Thunderbolt took to the skies over Rechlin, a crowd gathered. German engineers, mechanics, and officers stood on the edge of the airfield, curious to see how this hulking American fighter could possibly fly. It was early morning, cold, gray, and quiet, except for the deep growl of the R2800 Double Wasp engine. When the pilot throttled up, the sound shook the ground. The Luftwaffe test pilot, an experienced veteran who had flown nearly every German fighter in service, expected a slow, heavy takeoff. Instead, the Thunderbolt surged down the runway with surprising power, lifting smoothly into the sky. Its acceleration startled him. As the plane climbed, the torque of the massive radial engine fought against the controls. But once stabilized, the aircraft felt solid, steady, like a flying fortress in fighter form. The pilot banked, rolled, and dove. He had heard reports that the Thunderbolt handled poorly in tight turns, and while it was no Spitfire, its balance impressed him. The visibility from the cockpit was excellent, and the flight controls, though heavy, responded predictably. Then he pushed the throttle forward and began to dive. At over 400 miles per hour, most Luftwaffe fighters began to struggle. Compressibility, a deadly aerodynamic effect, could lock their controls and send them spiraling into the ground. The P-47, however, handled differently. It cut through the air like a bullet. The pilot pulled hard, expecting the wings to shudder or the fuselage to strain. Instead, the aircraft stayed stable. The dive deepened, 500 miles per hour, then 550. The controls stiffened, but the Thunderbolt remained intact. When the pilot leveled out, He realized what the Germans had underestimated. The Thunderbolt was not a dogfighter. It was a dive fighter. Its strength lay in altitude and power, not agility. It could dive faster than anything in the Luftwaffe and pull out alive. One engineer on the ground reportedly muttered, "This is no fighter, it's a hammer." After landing, the pilot stepped out, silent for a long time before speaking. When he did, his words were simple. "This plane is built to win a war of endurance." He told his superiors that the Thunderbolt's design made it nearly impossible to kill in combat. Its radial engine could take damage that would destroy any inline engine aircraft, and its sheer size protected its pilot from what would otherwise be fatal hits. At Rechlin, engineers dissected its construction layer by layer. They marveled at how every system had a backup. Even if a cylinder failed or the oil lines ruptured, the Thunderbolt could keep flying. And with its 8 Browning M2 machine guns, it could unleash over 7,000 rounds per minute, enough to shred any target it met. It was then that the Luftwaffe realized what they were truly up against. The Americans had built not a masterpiece of precision, but a masterpiece of production. A fighter that could be built by the thousands, flown by men with minimal training, and still dominate the skies through brute endurance and overwhelming power. One German report concluded, "The enemy no longer fights for perfection. He fights for persistence. And persistence, it seems, is winning." The German engineers at Rechlin continued their study with growing disbelief. They had tested British Spitfires and Hurricanes before, elegant machines built with finesse and precision. But the American Thunderbolt was something entirely different. It looked almost crude up close. Rivets everywhere, thick armor plating, and a massive radial engine that seemed to defy all principles of aerodynamics. Yet the more they studied it, the more they realized it was a masterpiece of rugged efficiency. The engineers dismantled sections of the fuselage, measuring every part. What astonished them was how forgiving the aircraft was. The tolerances were wide enough to allow for mass production. Panels could be replaced quickly. Components were standardized, interchangeable between factories. The Germans, accustomed to handcrafted perfection, were stunned. One engineer wrote in his notes, "It is not elegant, but it works. And it can be built faster than we can shoot them down." Then came the armor tests. The Luftwaffe technicians fired machine guns into the Thunderbolt's fuselage at various ranges. The bullets barely scratched the surface around the engine and cockpit. The R2800 engine, shielded by the thick radial front and oil cooler rings, could take damage and keep running. The engineers were particularly fascinated by the plane's cooling system. Most German fighters, like the Bf-109 and FW-190, use liquid-cooled engines. Powerful but fragile. A single bullet through the coolant line would doom the aircraft within minutes. The Thunderbolt's air-cooled design, however, eliminated that weakness entirely. It was a revelation. To the Germans, who prized speed and precision, such an approach seemed primitive. But in the brutal reality of air combat, simplicity often meant survival. The Americans had chosen practicality over perfection, and it worked. One officer overseeing the tests remarked grimly, "You could fly this thing home with half the engine gone." The Thunderbolt's sheer size also impressed and unnerved the German evaluators. It was enormous for a single-seat fighter, dwarfing the sleek Messerschmitts and Focke-Wulfs beside it. But that size gave it another advantage: range. With drop tanks, it could escort bombers deep into German territory and still have fuel to fight. For the Luftwaffe, this was a nightmare. Up to that point, Germany had relied on its fighters' ability to intercept Allied bombers before they reached their targets. The appearance of the P-47, soon followed by the even longer-range P-51 Mustang, shattered that strategy. By late 1943, reports from the front confirmed what the engineers already suspected. Thunderbolts were cutting down German fighters over France and the Netherlands, flying higher and farther than anyone thought possible. Their heavy guns tore through bombers, trains, and even tanks. To the German high command, it became clear the Americans had found their answer to air superiority, not through finesse, but through unstoppable force. As one Luftwaffe officer said after reviewing the test data, "It is not the machine that frightens me, it is what it represents. A nation that can build 10 of these for every one of ours cannot lose." By the winter of 1943, the tests on the captured Thunderbolt at Rechlin had moved from the hangars to the skies. German test pilots, men who had flown everything from nimble Bf-109s to experimental jets, were eager to see how this massive American fighter behaved in the air. Many expected it to be sluggish, perhaps even dangerous. What they found instead shocked them. The pilot who took the Thunderbolt aloft that morning later recalled his surprise. It climbed slower than a Messerschmitt, yes, but once it leveled out, it was like a rock on rails. Stable, unshakable. At high speeds where many German aircraft began to tremble or lose control, the Thunderbolt held firm. Its heavy frame, powered by the Pratt & Whitney R2800 engine, gave it an almost unnatural steadiness. The engineers on the ground watched in disbelief as the plane dove at full throttle, leveling out cleanly even after reaching terrifying speeds. Its thick wings and massive airframe absorbed the stress without flinching. One observer noted, "It looks like it shouldn't fly, yet it flies better than most of ours." The Germans began to test the aircraft's firepower next. 8.50 caliber Browning machine guns, 4 in each wing, could unleash nearly 100 rounds per second. During firing trials, the noise was deafening, a wall of sound that tore through targets like paper. The fire pattern was dense, deadly, and brutally efficient. The Luftwaffe's standard fighters, armed with 20mm or 30mm cannons, relied on accuracy. A few well-placed hits could down an enemy, but hitting fast, maneuvering bombers wasn't easy. The Thunderbolt's approach was different. It didn't need precision, it relied on volume. Its pilots could spray destruction across an entire bomber formation or rip apart a ground convoy in seconds. One German report from the Rechlin facility stated bluntly, "The fire concentration is overwhelming. A single pass is often fatal." Then came the turning tests. Here, finally, the Germans thought they would expose the Thunderbolt's weakness. Against a Bf-109 or an FW-190, it turned slowly, its heavy frame resisting tight maneuvers. But when pilots began to simulate combat scenarios, they quickly realized that turning wasn't the Thunderbolt's main strategy, diving was. The P-47's immense weight, combined with its powerful engine, allowed it to dive faster than any German plane could follow. In dogfights, that meant survival. If a Luftwaffe pilot got behind a Thunderbolt, the American could simply push the nose down and drop like a stone, leaving his pursuer behind or watching him crash trying to keep up. One test pilot described it with awe. "It falls from the sky like a bomb, and then it climbs again as if nothing happened." The Germans began to understand why their aces had started reporting strange encounters. Thunderbolts that refused to die, that escaped impossible situations, that returned again and again no matter how hard they were hit. At first, the Luftwaffe had mocked the Thunderbolt as an overweight brute. Now they knew better. Beneath its bulky frame was an aircraft perfectly adapted to the brutal, unforgiving nature of modern air war. As one Rechlin engineer wrote in his final notes, "This machine is not about grace. It is about endurance, in metal and in men." The laughter had faded from the test halls. The German pilots no longer joked about the American flying barrel. They looked at it with something far more dangerous: respect. By early 1944, the German engineers at Rechlin had enough data on the Thunderbolt to draw conclusions, and they weren't comforting. What they had once dismissed as a crude, heavy fighter had turned out to be a marvel of design philosophy. Every inch of the aircraft had been built not for elegance or agility, but for survival, range, and power. They began to study its armor in detail. The cockpit was surrounded by thick steel plating, forming a shell that could deflect small-caliber rounds and shrapnel. The bulletproof glass canopy was far thicker than anything on a German fighter, protecting the pilot even during head-on attacks. The fuel tanks were self-sealing, lined with layers of rubber and treated fabric that closed around punctures. The engineers were stunned. German aircraft were designed to be fast, agile, and light, which meant sacrificing protection. The Thunderbolt, by contrast, seemed almost indestructible. One German test pilot reportedly said after examining it, "It's not a fighter, it's a flying tank." In one test, the Germans simulated combat damage. They riddled the fuselage with small caliber rounds and tested engine endurance with shrapnel impact. The result was astonishing. The Thunderbolt's Pratt and Whitney R2800 kept running even after multiple hits. The radial engine, air-cooled rather than liquid-cooled like most German designs, could lose cylinders and still produce enough power to keep the plane airborne. This was revolutionary to the German engineers. Their high-performance liquid-cooled engines, like those in the Bf-109 and FW-190D, were precise but fragile. A single bullet through a coolant line could doom the aircraft within minutes. The Thunderbolt, by contrast, could be shot full of holes and still limp home. They realized the Americans had built a fighter for a new kind of war. One fought across oceans and continents, where reliability and endurance mattered more than finesse. Every Thunderbolt was a product of mass production and mechanical resilience, traits that mirrored the nation that built it. An engineer at Rechlin summarized it in a report: "The Americans designed for the soldier, not the engineer. It is built to be used, not admired." Meanwhile, at the front, the Luftwaffe's view of the Thunderbolt was changing fast. Reports from squadrons over France and the Low Countries began to echo the engineers' conclusions. Pilots described P-47s surviving direct cannon hits, diving out of combat and returning the next day. They complained that its firepower shredded anything in range, even armored vehicles and trains. When the Allies began deploying the P-47 in greater numbers for ground attack missions, the results were devastating. With its heavy armor and 50 caliber guns, it could dive onto convoys, airfields, and rail lines with impunity. The Luftwaffe quickly learned that intercepting a Thunderbolt was risky and often fatal. At Rechlin, engineers compared the combat data with their own test results. It all pointed to the same conclusion. The Thunderbolt was not a fluke. It was the inevitable product of an industrial giant capable of producing thousands of machines that could take punishment and keep fighting. For the German engineers, the testing was no longer a technical exercise. It had become a moment of realization, a glimpse into the scale and philosophy of the enemy they faced. They saw that while the Luftwaffe built masterpieces, the Americans built workhorses, machines that didn't need to be perfect because there were so many, and because they simply refused to fail. The laughter that once filled the testing grounds had vanished completely. The Germans no longer mocked the Thunderbolt. They studied it with grim respect, understanding that behind its bulky frame lay a truth they could no longer ignore. The sky now belonged to those who built for endurance, not elegance. As 1944 pressed on, the Thunderbolt became an unmistakable presence over Europe, its deep, throaty roar echoing through the clouds long before its silhouette appeared. To German soldiers and pilots alike, that sound became a warning. It meant that the Americans were near, and that nothing on the ground was safe. The Luftwaffe, stretched thin and losing air superiority, had to face a terrifying reality. The P-47 Thunderbolt wasn't just a fighter. It was a symbol of the American war machine itself. Tough, loud, relentless, and built in numbers the Germans couldn't hope to match. At Rechlin, engineers continued their tests, this time focusing on the Thunderbolt's diving ability. They had heard the combat reports. German fighters were losing pilots trying to follow Thunderbolts in steep dives. Many assumed it was exaggeration until they tested it themselves. They took the captured P-47 into a controlled dive from high altitude. As the speed increased past 400 miles per hour, then 500, the engineers waited for instability, but the aircraft held steady. The heavy weight that had once seemed a flaw became an advantage. It sliced through the air with terrifying momentum. German test pilots were astonished. Most of their aircraft, the Bf-19s, the FW-190S, began to shake violently at such speeds, risking structural failure. But the Thunderbolt could dive like a stone and recover safely thanks to its sturdy frame and advanced control surfaces. It was, as one pilot described, a fighter that fell like a bomber and climbed like a storm. The Americans had built a plane that turned mass into a weapon. Its strength wasn't just in its guns or armor, but in the physics of its design. In air combat, that meant one thing. If a Thunderbolt dove, you couldn't catch it, but it could catch you. At the front lines, this translated into deadly effectiveness. German pilots began to refer to Thunderbolts as juggernauts, an apt nickname that echoed the plane's allied call sign, Jug. Pilots learned to fear its durability. There were countless reports of P-47s returning to base with entire sections of wing shredded or cylinders missing from the engine, yet somehow still flying. One Luftwaffe ace reportedly said, "You can shoot a P-47 until your guns are empty, and it still comes back tomorrow." The engineers at Reckland took these reports seriously. They ran stress simulations, calculated ballistic damage, and concluded that the aircraft's radial engine design made it uniquely survivable. Unlike inline engines, which could be killed by a single bullet through the coolant system, the Thunderbolt's air-cooled radial engine could take hit after hit. It didn't need coolant, it didn't overheat easily, and it could keep running under punishment that would have destroyed any German fighter. It was an unsettling revelation. The Thunderbolt was not an accident. It was deliberate. Every weakness the Luftwaffe saw had turned out to be a strength. Its weight gave it power in dives. Its bulk gave it protection. Its simplicity gave it reliability. And while the Germans were refining their machines into masterpieces, the sleek, high-maintenance wonders like the FW-190D or the Me-262 jet, the Americans were perfecting the art of mass production. Each Thunderbolt was part of an endless tide of steel and fire, flowing across the Atlantic and over Europe. For the German engineers, it became clear that the war in the air was no longer about who had the better pilots or the most advanced designs. It was about who could build faster, repair quicker, and endure longer. The Thunderbolt was proof of that philosophy. It was a machine that didn't have to be the best. It only had to be unstoppable. As one German officer wrote in his report, "We sought perfection and found fragility. They sought power and found victory." The laughter that once echoed through the Luftwaffe's halls when the Thunderbolt was first mentioned had long disappeared. Now there was only silence, and the distant sound of engines that never seemed to stop. By late 1944, the Thunderbolt had earned its reputation as one of the most feared aircraft in the skies of Europe. To the Allies, it was a symbol of strength. To the Germans, it had become a problem they couldn't solve. The Luftwaffe had once dominated the air. In 1940 and 1941, their Messerschmitts and Focke-Wulfs were unmatched. They were sleek, elegant machines, the product of precision engineering and highly trained pilots. But now, those same pilots were facing an enemy that didn't play by the same rules. An enemy that built machines for endurance, not elegance. When a captured Thunderbolt arrived at the Reschland Test Center, it was examined again, this time by a new team of engineers desperate for answers. They wanted to know how such a heavy, bulky plane could perform so well in both dogfights and ground attacks. What they found only deepened their respect and their dread. Inside the cockpit, everything was built for survival. The seat armor was thick, the fuel tank self-sealing, and the canopy wide and clear, giving the pilot unmatched visibility. The cockpit layout was functional, simple, almost crude, but efficient. It allowed pilots to focus on fighting, not fiddling with instruments. The Germans noticed how easy it was to maintain. Panels opened quickly. Major systems were accessible. Even in field conditions, American ground crews could repair battle damage within hours. A Thunderbolt shot up in the morning could be back in the air by evening. To German eyes, accustomed to fine-tuned aircraft that required delicate handling and maintenance, it was almost absurd. But it worked. In combat, the P-47 was transforming warfare from above. It wasn't just fighting enemy planes. It was hunting tanks, trains, and convoys. With 8.50 caliber Browning machine guns, it could shred entire columns of vehicles in a single pass. Its dive bombing capability made it the terror of German ground troops across France and the Eastern Front. The Germans began calling it Der brüllende Tod, the roaring death. Its heavy engine roar filled the skies before the first bullet struck. To soldiers on the ground, it meant destruction was seconds away. What struck the engineers most was how the Thunderbolt's versatility reflected the American war philosophy. It was built to adapt. The same plane that had been designed for high-altitude bomber escort over Europe could within months become a low-flying ground attacker over Normandy or the Ardennes. No German aircraft had that kind of flexibility. The Luftwaffe's designs were specialized. A fighter was a fighter, a bomber was a bomber. But the Americans had created something that could do both. As one engineer noted in a 1944 report, they have built a machine that answers every demand of the war, not just one. The Rechlin pilots continued their flight tests, pushing the Thunderbolt through maneuvers against captured German aircraft. Again and again, they were shocked. While it could not match the agility of the Bf-109 in a tight turn, its energy retention in climbs and dives was extraordinary. Once it built momentum, it could dominate a fight through sheer force and power. One pilot remarked, "It feels less like flying and more like wrestling with a force of nature." By now, even the most skeptical Luftwaffe officers were forced to admit what they had once laughed at, that this ugly American machine had changed the balance of the skies. They compared it to the Republic P-43 Lancer, its predecessor, and realized how far the Americans had come in just a few short years. The Thunderbolt wasn't just an aircraft, it was a statement. It represented industrial evolution, tactical adaptation, and the raw determination of a nation that refused to lose. In a war that had begun with German pilots laughing at Allied design, the tables had turned completely. Now it was the Luftwaffe pilots who looked up and prayed they wouldn't hear that low, thunderous roar. One captured German pilot said after the war, "We used to think they built with steel and oil, but they built with something else, willpower." And as the German engineers closed their final reports on the P-47, they knew they were not just studying an aircraft. They were studying the embodiment of an entire nation's strength. By the winter of 1944, the P-47 Thunderbolt had become more than a fighter. It was a symbol of Allied dominance in the skies. From the snowy forests of the Ardennes to the bomb-scarred railways of Germany, its thunderous engines echoed through the clouds like a promise or a warning. For the German engineers and pilots who once dismissed it, the Thunderbolt now represented something deeply unsettling. They had built their faith in precision, in machines that embodied perfection, but the Thunderbolt was proof that victory belonged to the practical, not the perfect. When German test pilots at Rechlin took the P-47 back into the air for extended flight trials, they couldn't help but admire it. It was brutally simple to fly at high speeds and almost impossible to kill. Even when they simulated battle damage, holes in the wings, a failing engine, partial control loss, the plane stayed stable, responsive, determined. As one of them wrote in his report, "It is as though the aircraft does not wish to die." On the front lines, the P-47 was rewriting air combat. It dove like a stone, screamed through enemy formations, and struck with overwhelming force. Its rugged frame could withstand the tremendous stresses of steep dives, a tactic American pilots used to devastating effect. German pilots soon learned that chasing a Thunderbolt into a dive was suicide. The plane's massive radial engine allowed it to plunge faster than anything in the Luftwaffe arsenal. When it finally pulled up, the pursuing fighters, lighter, more fragile, often tore their wings apart trying to follow. To the German engineers, the Thunderbolt's success was a lesson in industrial philosophy. They saw how the Americans had designed their weapons for mass production, for endurance rather than artistry. Every component of the P-47 could be built in multiple factories, replaced quickly, and adapted for new missions. By contrast, German aircraft like the FW-190 and ME-109 were precision machines, demanding specialized materials and skilled craftsmen, luxuries the Reich could no longer afford. The Luftwaffe was bleeding both pilots and parts, while the Allies flooded the skies with replacements. As one captured Luftwaffe officer later said, "For every pilot we lost, they built 10 more planes." The engineers noted another remarkable feature: the Thunderbolt's engine, the Pratt & Whitney R2800 Double Wasp. It was a masterpiece of American engineering, a 2,000 horsepower radial beast that could take punishment and still deliver performance. Unlike the liquid-cooled engines in German fighters, the Thunderbolt's air-cooled design made it almost invulnerable to small arms fire. A single bullet to the coolant system could doom a Messerschmitt. For the Thunderbolt, it meant nothing. That simplicity, that rugged efficiency, was both its secret and its triumph. By early 1945, German reports described the P-47 as a tank with wings. It was not graceful, but it was unstoppable. The pilots who had once mocked its size now feared its firepower. 8 Browning machine guns, each capable of firing 850 rounds per minute, could turn a convoy into wreckage in seconds. One German soldier who survived a Thunderbolt attack on a rail line near Cologne wrote, "The ground shook before we even saw them. Then the sky ripped open." The Luftwaffe's engineers also noticed the American pilots themselves, their style, their tactics. They didn't rely on heroics or intricate maneuvers. They trusted their machines and worked in disciplined teams. Each pilot's strength came from coordination, not individual brilliance. It was the opposite of the German approach, which had long glorified the lone ace. The Thunderbolt symbolized that difference: industrial, collective, relentless. As the war turned against Germany, the engineers' admiration for the Thunderbolt carried a hint of despair. They understood that no amount of innovation could close the gap anymore. The Americans had built a war machine that could not only win battles but replace itself endlessly. The Thunderbolt wasn't just a weapon, it was a philosophy in flight. One test engineer, in a private note never meant to be published, wrote, "The Americans fight with factories. We fight with pride. Factories win wars." By then, the laughter had stopped. The German engineers, once so confident in their designs, now stood humbled by a machine that embodied everything they had underestimated: power, practicality, and persistence. By the spring of 1945, the skies over Europe belonged to the Thunderbolt. Once mocked as too heavy, too slow, too crude, now it was the most feared sound a German soldier could hear. From Normandy to Berlin, its roar meant one thing: destruction was coming from above. The Luftwaffe was no longer the hunter. It had become the hunted. Every airfield, every convoy, every train, nothing was safe from the P-47. American pilots, flying from bases in France, Belgium, and England, swept across the sky with ruthless precision. Their targets weren't just aircraft anymore. They were fuel depots, factories, bridges, and the lifelines of a dying Reich. The German engineers at Rechlin, who had once tested the Thunderbolt with detached curiosity, now watched helplessly as their own country burned beneath its wings. Reports came in daily: columns of armor destroyed, rail networks cut apart, fighter squadrons wiped out before they could even take off. One Luftwaffe officer described it simply: "They own the day." For the Germans, what made the Thunderbolt terrifying wasn't just its power, it was its endurance. A P-47 could stay in the air for hours, cover hundreds of miles, and return for another run before refueling. The Allies had mastered logistics in the air, just as they had on the ground. The Luftwaffe, meanwhile, was crippled by shortages. Fuel was scarce, spare parts were rare, and the once proud squadrons were filled with inexperienced pilots. Against that backdrop, the P-47 was an unstoppable storm, an embodiment of industrial warfare at its peak. German test pilots had one last chance to face the Thunderbolt in controlled mock dogfights. They pitted captured aircraft against the best of the Luftwaffe, Focke-Wulf 190s and Messerschmitt 109s. On paper, the results were predictable. The German fighters could outturn and outclimb the American brute. But in practice, things were different. The P-47's power dive, its sheer speed and descent, made it nearly impossible to trap. Its guns, once locked on target, shredded anything in their path. A German pilot later confessed in an interview, "When you saw that big machine coming at you, smoke trailing, guns flashing, it was like facing a storm. You didn't fight it, you survived it." By this stage in the war, the Thunderbolt had become the hammer that broke Germany's military backbone. It strafed retreating forces, destroyed communication lines, and attacked armored divisions with deadly precision. Its pilots flew low, fearless, and relentless. To the German soldiers below, it was terrifying. But to the engineers who had once laughed at it, it was fascinating. They saw in the Thunderbolt the realization of something Germany had never achieved: a weapon built not for prestige, but for endurance. A report from early 1945, found in the ruins of a Luftwaffe testing site, summed it up bluntly. The P-47 is a war machine designed without vanity. It is ugly, but it wins. Even as the Reich collapsed, the engineers continued their studies. They measured bullet holes, inspected captured wrecks, and noted the thickness of the armor plating. They couldn't help but admire how well the Americans had balanced every element: protection, power, and mass production. The Thunderbolt wasn't the fastest nor the most agile, but it could be built by the thousands. For every one destroyed, another took its place within weeks. Germany, with its precision-crafted but fragile war machine, simply couldn't compete with that scale. One captured German engineer told Allied interrogators, "You did not build an airplane. You built an army of them." In the end, the Thunderbolt symbolized everything that had changed in modern warfare. No longer did wars favor elegance or technical mastery alone. They were won by industry, logistics, and endurance. The German engineers realized that they had lost long before Berlin fell, not in the skies, but in the factories. As one of them reportedly said after the war, "We built dreams. They built machines." By April 1945, there was no laughter left in the hangars of Rechlin. The men who had once ridiculed the American flying tank now watched it dominate the skies over their homeland. The P-47 had proven not just the power of a machine, but the power of a nation's will to build, endure, and win. When the war finally ended in May 1945, the skies over Europe fell silent. The engines that had once shaken the earth were quiet now, and the men who had flown them, on both sides, were left to reckon with what they had witnessed. Among the defeated in hangars and captured testing centers, German engineers studied the wreckage of 1,000 battles, and one aircraft stood above the rest: the Republic P-47 Thunderbolt. The Germans had entered the war believing in the supremacy of engineering elegance, that precision and complexity were the hallmarks of power. Their Messerschmitts and Focke-Wulfs were masterpieces of design, born from genius but dependent on perfection. The Thunderbolt, by contrast, was brute force made beautiful in its simplicity. Now, as the war's end drew near, German engineers and test pilots admitted a quiet truth among themselves. They had underestimated not just an airplane, but an entire philosophy of warfare. The P-47 was heavy, loud, and industrial, the embodiment of American manufacturing power. It could dive faster than any German fighter, shrug off damage that would destroy others, and still deliver punishing firepower with deadly accuracy. A former Luftwaffe colonel later said, "We thought we were fighting pilots. We were fighting factories." Captured Thunderbolts were tested at Rechlin and other Luftwaffe facilities in the final months of the war. The German pilots who flew them were stunned. The cockpit was spacious and comfortable. The controls were sturdy but smooth. The radial engine, so often mocked for its bulk, was practically indestructible. In one test, a German engineer deliberately cut the engine mid-flight to simulate failure. The aircraft glided effortlessly and restarted within seconds. It was a machine built to survive mistakes, something alien to the Luftwaffe's doctrine of perfection. A test report dated February 1945 concluded, "The American aircraft is not refined, but it is enduring. It forgives the pilot. It forgives the battlefield." After the war, Allied and captured German engineers worked side by side in reconstruction efforts. Some of them, now employed under American supervision, revisited the Thunderbolt's blueprints. They studied its engine design, its electrical redundancy, and its manufacturing process. One German specialist, once a critic of the aircraft, reportedly said while examining its components, "They did not build art. They built victory." He wasn't wrong. Between 1941 and 1945, more than 15,000 Thunderbolts rolled off American assembly lines, more aircraft than Germany could have dreamed of producing. And behind every one of them was a nation that had turned its entire economy into a weapon. In the post-war years, many former Luftwaffe officers were asked what they feared most about the American Air Force. Some said the Mustang, others the Flying Fortress. But those who had fought on the ground, who had watched their convoys torn apart by fire from above, always gave the same answer: the Thunderbolt. They remembered its sound before they ever saw it, the low guttural roar that rolled across the fields like thunder before the strike. It was a sound that meant death, and more importantly, inevitability. One soldier later recalled, "When the Thunderbolt came, There was no point in running. It would find you. In the decades after the war, the Thunderbolt became a legend, not because it was beautiful, but because it was unstoppable. Pilots who flew it described it as a machine that protected them, not one they had to protect. It was the aircraft that always brought them home. Even in the age of jets and missiles, the lessons of the Thunderbolt remained. It proved that power and endurance could triumph over precision and complexity, that survival was the greatest weapon of all. A German engineer, interviewed years later, summarized it best. "We spent the war building perfect machines for a perfect world. The Americans built imperfect machines for the real one. That is why they won. Today, the last surviving Thunderbolt stands silent in museums, gleaming silver wings that once darkened the skies of Europe. And in those wings lies a story not just of battle, but of revelation." The Germans had laughed when they first saw the Thunderbolt. Too heavy, too crude, too slow. But when they tested it, when they saw what it could endure, the laughter stopped. They had witnessed something they could neither match nor destroy, the raw, relentless power of a nation that built for endurance, not elegance. And in that revelation, they understood the truth of modern war. You don't win by building perfection. You win by building what survives. If you enjoyed this video, don't forget to like, comment, and subscribe for more World War II stories.